Hey Space Friend, has this ever happened to you? You're just trying to get through a beginner Arduino tutorial, but they keep throwing all these words at you that you don't understand. Same. When I first got started with Arduino, I had to do a lot of outside research on most of the beginner project tutorials that I found. So I'm going to try and save you a little bit of time and throw down some terminology that initially confused me and break it down into more jargon-free terms. I know there's a lot more than this that comes up for beginners, so if there's anything specific you'd like to see covered, just let me know in the comments and I can cover it in a future video. First, 8-bit. You may have heard that the Arduino Uno has an 8-bit microcontroller. A bit is the smallest amount of digital data that can be transmitted over a network. It's a single unit of digital information and is represented by a 0 or a 1. Their original use was ye old punch card systems that mechanical computers used to perform computations. The binary information, the zeros and the ones, was stored in the mechanical position of a computer's level or gear. Now those zeros and ones are represented by an electrical voltage or current pulse. Today 8-bit is generally associated with slow computers and low resolution. This is because it's indicating the maximum number of bits that the device can operate or execute at a time. Think about it like a desk with multiple drawers in your spaceship. Each drawer can store 8 objects. The capacity of each drawer and the number of drawers determines how many bits the microcontroller can process at once. This is why you can't do highly advanced projects with an Arduino. The boards with an 8-bit microcontroller can only operate on 8 binary digits at a time. You might hear integrated circuits or ICs called chips or microchips. An IC is a fundamental building block of modern electronics. All the components of an integrated circuit are built up on a wafer made of a semiconducting material, usually silicon, with a collection of thousands or millions or billions of electronic components like transistors, resistors, capacitors, diodes, and more packed onto a tiny chip. This is the little black chip that you can see on most circuit boards. A wafer is a piece of silicon or some other semiconductive material in the form of a very thin disk. They serve as a substrate for integrated circuits. Each component on an IC is tiny, usually even microscopic, and are intricately weaved together along with a complex layering of wafers and copper. The wafer is cut or diced into many pieces, each containing a copy of the circuit. Each individual piece is called a die. ICs are incredibly complex. The individual components are embedded directly into the silicon crystal instead of just being mounted on top of it, and the wafer and copper layers are very thin and fragile. The IC die is far too small for anything to be connected to or soldered onto it, which is why we package the die into a black chip that forms the basis of hundreds of electronic devices. The package encases the IC die and allows us to more easily connect it to devices. The pins on the outside connect to other parts of a circuit. All ICs are polarized, and each pin is unique in terms of its location and function. Most ICs use notches or dots so that you can tell which pin is first. The pin numbers then increase counterclockwise around the chip. This black box is the Arduino's IC package. Microcontrollers are a kind of integrated circuit, and when we call the Arduino a microcontroller, this is the specific part being referred to. A terminal is the point at which a device's conductor or component come to an end. A conductor being the object or material that allows the flow of electrical current. A terminal could be something like the end of a wire or the endpoint of an electrical connector that creates a point where external circuits can be connected. On a potentiometer, these parts are all called terminals. The anode and cathode of an LED are also terminals because electrical polarity is a type of terminal. Polarity refers to which side of an entity has a greater number of electrons. The side with a higher number of electrons is considered the negative polarity, and the remaining side is the positive polarity. Polarity also determines the flow of current. Many batteries also have a cathode, which is the protruding side and is the positive terminal, and an anode, which is the flat metal disc and is the negative terminal. This is the opposite of anodes and cathodes on something like an LED. With an LED, the positive side is the anode and the negative side is the cathode. Encoders and decoders are used to convert data from one form to another. It's a digital circuit that converts sets of binary inputs into a unique binary code. They're useful for devices that need to operate with high speed and high accuracy. The encoder is a logic circuit that accepts one or more inputs and generates a multi-bit output code. An example is a microphone. Your voice is a real-world entity, and the encoder inside the microphone encodes your real-world voice into electrical pulses. These are just a few examples of the so many terms that can be confusing to beginners, myself included. If you want to see project tutorials where we put terminology like this into practice, check out my channel where I've got beginner-level Arduino tutorials set to the theme of fixing this broken spaceship. And there's so many 8-bit IC terminals and encoders to fix in here. Don't fact check the logic of that sentence, please.